Is it gonna start? Hmm. I think this today is day 2 of this lesson. So yeah, 3.02. Is this day 2, guys? Take a look. This is day 2. So that means you have a quiz today after this. Yeah, get that done and then enjoy your 3-day weekend. So 3.02 inverse trig function. So we're going to calculate the inverse of trig function. So make sure you have your unit circles, preferably printed out. Also have your calculators ready and have them in radian mode. Oh, by the way, before I get started in this lesson, your part 2 submissions, I graded them very harshly on one of the questions. It was the one involving looking at the tree or whatever and stepping back some feet. Um, I put a lot of comments saying, do not round your work. So a lot of you did it in basically 3 parts, and you rounded in each part. You can't do that in math. Your teachers in the past should have said, never round your work if you can avoid it. So people that are typing in stuff, they hit enter and they write down they're rounded, even if it's like 10 places long or whatever, your decimal, that's still rounding. You need to keep it in that exact form, meaning whatever you typed in to get that decimal, that's the exact form. You want to use that in your final, I guess, step. You type that in, hit enter, and then the answer you get, that's what you round. So even though a lot of you, even though you rounded in the previous 2 parts, if you did part 2, you know what I'm talking about. You rounded, you still got the right answer, but I still marked it wrong because I didn't like that you rounded, because rounding is wrong. You shouldn't round until the final answer. That's important. So fix it and resubmit it. You have a typo there, Antonio. It shouldn't be Apple Calc is usable. It should be Apple Calc is useless. All right, let's keep going, guys. Our 3.02, day 2. Let's get this done. All right, we're being recorded. All right, inverse functions. So in order for a function to have an inverse, it must pass the vertical and horizontal line test. So if you think back, maybe your freshman year, you were taught, well, for something to be a function, it has to be a one-to-one, or it has to pass the vertical line test, meaning if you draw a vertical line on your graph, it should only hit how many points at most? Points at most. Should the vertical line test? Only one, yeah. So your vertical line, no matter where you draw the vertical line on your graph, it should only hit 1 point. If it hits more than 1 point, it is not a function. An example of, well, not a function would be like a circle. A circle, a vertical line, like right in the middle, you hit 2 points, right? A square root, a plus or minus square root, you got to graph it in 2 parts, but it creates a sideways U. That's not a function either. So if you think about like a sine wave, the wavy line that we learned yesterday, if you happen to do the inverse, so remember x's become y's, another way to do it I taught you last term was you can highlight the graph in like pencil, dark pencil, and then fold it at an angle. Then you rub it and then you unfold it, and then wherever it transfers, that would be the inverse function. And that's what's going on in these pictures here. So these are, if you switched x and y, you would get this, you get this, and then for tangent, you would get this. So these are the inverse functions. Well, if you notice, these do not pass the vertical line test. So that's why it says horizontal. So the original must pass both vertical and horizontal. If it doesn't pass the horizontal, the inverse will not be a function. All right. So is that clear of this little blurb we have here? All right. Well, there's a fix for this. We have to create domain restrictions. So for the domain, remember, domain is the x's. I should have asked you that question. Hey guys, what is domain? What variable? Oh, x's. Very good. Thank you. Thank you for answering. All right, x's. Yep, the x's. And your range is your what variable? Your y values. Very good. All right. So we have to create domain restrictions. And these restrictions basically this creates the little snippet of the graph of the piece that doesn't repeat. So for the sine wave here, it's from here to here, and then it'll repeat after this point. So we cut it off. So the domain for sine is from negative pi over 2 to pi over 2. That is the domain restriction for this. So this passes the vertical line test, and now it passes the horizontal line test. Now, this graph does go to the left a little bit, so I didn't want to cut off this label. So this should actually stop right here, and then this piece should stop right here. And then you can kind of visualize that. You can just kind of cross it off, and then you can see it from this point to this point, and then coming back down, then you're going to have some repeats and it fails the horizontal line test. Same thing from over here. The cosine, that restriction is from 0 to pi. So from this point to this point, it passes the vertical and horizontal line test. So that means the inverse of that will also be a function. And then same thing for tangent. That's the easiest one just because you already have a predefined asymptote at negative pi over 2 and pi over 2. So that's the restriction. If you notice, we have parentheses here and here. That means, well, what does that mean? You tell me, what does that mean? Yeah, not included. It's restricted. It's an asymptote. Yep. So because we have the parentheses, that's a hole in the graph, right? It's a hole. It's an asymptote. So that means it'll get close to these values, but we can't actually use them. These are hollow points, and then the brackets represent solid points on the graph. So that's important to remember too. All right, so this is important to write down. These restrictions, we need to use these when we actually find out the inverse functions of those, which you'll see in the next page or two. All right, so make sure you have these domain restrictions written down in your paper for all three fundamental trig functions. Take a moment to write those down if you haven't. All righty. Okay, graphically, I put these on paper, well, on your screen to show you using the unit circle what that domain restriction is. So for sine, it's from negative pi over 2 to pi over 2. So the unit circle, remember, going clockwise is going negative, and then going counterclockwise is going positive. So that's why we start at negative pi over 2. So from negative pi over 2, increasing to pi over 2. So this is important to make this association. Negative pi over 2 to pi over 2. And you also may want to, I didn't, but you can also even rename these values here. I just copied and pasted the unit circle, but so 11 pi over 6, what should this actually become right here? Go ahead and write it in chat. So instead of having 11 pi over 6, what should it be instead? Oh, he is correct. It is negative pi over 6. Yep, negative pi over 6. Well, and that's kind of makes sense, right? Because going from here to here is positive pi over 6. So going opposite, negative, would be negative pi over 6. So then what should this radian actually be? Pi over 4. Yep. And then what should this one be? Negative pi over 3. Pretty simple, okay? That's important to know when doing these. All right, and the one for cosine, well, that's pretty easy because that domain restriction is from 0 to pi. So here's 0, and it goes, remember, it's positive, 0 all the way up to pi. This goes in the positive direction. Remember, counterclockwise is positive, so it's from 0 to pi. Pretty easy. And then for tangent, this one is just like sine. It goes from negative pi over 2, not including it. That's why I crossed it out, because you can't actually use it. And then it goes from negative pi over 2 all the way up to positive pi over 2. So again, just like sine, this would be negative pi over 6. This would be negative pi over 4. And this would be negative pi over 3. That's important. All right, we good? I like pictures. I think this is a good picture I added. All right, so the inverse. So like if you go to GeoGebra and you graph this, is what it would look like. And I showed you on the previous, actually I didn't show you the inverse yet. Yep, this is new. So if we graph the inverse based on the domain, remember x has become y's, y has become x's. So we flip-flop. And this is what you get. So the domain of the inverse, remember arc sine and inverse mean the same thing. So inverse sine or arc sine, they mean the exact same thing. So the arc sine looks like this. The domain of the arc sine is from -1 to +1. And then the range, so remember, domain and range flip-flop. We learned this last term. So the domain restriction of the original for sine was negative pi over 2 to pi over 2. So that means the range is now that. And that goes for all of these. This is the arc cosine graph, and this is the arc tangent.
Can you go back?
To here?
Yeah, so Araceli can take a snip of it.
Oh, sure. All right. All right. Well, so let's do some of these. So, and I was nice enough that I put them on the screen just so I can point, but you should have them in front of you too. All right. So let's do the first one together. So remember last unit, you were said, okay, I told you, all right, hey, what's the cosine of this degree? So last unit, I gave you the degree, and then from whether it being cosine, sine, or tangent, you had to pick out whether it was x, y, or the ratio x and y, right? Y over x. So inverse, instead of giving you the degree or radian, what am I giving you? Take a wild guess. And yes, I am giving you the coordinate. Yes, I am giving you the x value, and then you must tell me what the what is. Take a guess. Well, not the y, no. Okay, let me go back again. So last unit, I gave you the radian, you gave me the coordinate. So inverses, I'm giving you the coordinate, you are giving the radian. I know you guys learn quickly. Yes, yes. Don't overcomplicate what we're doing here. And I'm going to have that, what I just said, I'm going to have it written out on my last slide. So if you don't want to write it down right now, you don't have to. You can write it down at the very end. And we have to use the domain restriction. So the arc sine of 0, so I'm asking you, okay, when the x, remember cosine is x, sine is y, tangent is y over x. So when I ask you, I say, okay, so what is the radian when the x value, because cosine, is 0? So we go over to our diagram or that shows the restriction, the domain restriction. And for cosine, it is from 0 to pi, so 0 to pi. So when the x value, so where is the x value 0? Pi over 2. Yep, pi over 2. So you can see right here, x value is 0. So that means the radian is pi over 2. So that's the answer, pi over 2. And here's something really cool. I mean, not pi over 2. Hold on, did I miss? I think I mistyped that. It should be pi. Everyone type in inverse cosine of 0. I don't know why I have 1 there. It should be pi. Plot twist. Pi over 2, sorry. Do we get pi over 2 when you type in inverse cosine? Yeah. Yep. Okay. I mistyped that. Yep. That's a typo on my part. I am so sorry. Pi over 2. Okay. I hope I didn't mistype all of these. With my luck, I probably did. Nope. I just mistyped the first one. I'm good. I don't know why I did that. Sorry. All right. All right. So we got pi over 2. So again, when the x value is 0, the radian is pi over 2. You type it in, you hit enter, you get pi over 2 on your calculator. Awesome. All right. Let's do number 2. Inverse sine of radical 2 over 2. So I want to know, remember, we have to use the domain restriction. When we have the y value is radical 2 over 2, what is the radian? That's what I'm asking you. I'm getting 2 different answers. Some say pi over 4, some say 3 pi over 4. So when the y value is radical 2 over 2. Now remember, the sign restrictions, we have to use this one, right? If you use the wrong one and you choose a value that's like over here, for example, that is outside your allowed domain. So your answer needs to be between negative pi over 2 and pi over 2 inclusively. So make sure you're using sine. We have to use this one. All right, so let's try it again. What is the inverse sine of radical 2 over 2? Pi over 4? Pi over 4. Yep, radical 2 over 2 is y, so the radian is pi over 4. You can type this in, inverse sine of radical 2 over 2, hit enter, and your calculator should give you pi over 4. So really, all of these, you can just type them in and get an answer. I want you to be able to do it both ways, though. I want you to be able to use the domain restriction, use the diagram that I provided here to do it, but you can type it in to see your answer. It's important because, well, I'm going to tell you why it's important at the last slide. There is a reason. Yeah, doing it both ways is great. Plus, knowing how to do something more than one way, it makes you a smarter person. All right, everyone try number 3 and 4. I'm going to give you all, I think, 2 minutes should be good. A minute and a half. We'll say a minute and a half, yeah. Minute, 30 seconds. Got a whole 27 seconds left. Mm, that's good. That's good. Ooh, time's up. All right, number 3. What did all of you get? All right, so I got mixed numbers. So 5 pi over 3. All right, so 5 pi over 3. Let's see, where is 5 pi over 3? 5 pi over 3. Oh, 5 pi over, here's 5 pi. Okay, so here's a question for you. So this is inverse sine. The domain restriction is from negative pi over 2 to pi over 2. Does 5 pi over 3 fall within this domain restriction? It does not. Antonio, does not. 5 pi over 3 is much greater than this interval. Much greater. So you cannot use, so if your answer here is 5 pi over 3, it's wrong because it doesn't fall within the domain restriction. So go ahead, everyone type in inverse sine of negative radical 3 over 2 and hit enter. Negative pi over 3, yeah. If you think about it, it makes sense because here's the domain restriction. That we all agree this is where it's at, right? Because that's where the y value is, negative radical 3 over 2, right? But what, so, and that's going from, remember, you start at 0 and going this way, going clockwise is going negative. So this is negative pi over 3. You are not allowed to do a full rotation around, well, because there's a wall here. You are not allowed to go past this wall. You can go, whoops, I'm using my pointer and I don't even have my pointer on the screen. Yeah, there's a wall right here. So you can go up to here, but you can't go past it. You can't wind counterclockwise around to 5 pi over 3. You can go 0 to here, or you can go from 0 down to here. So that's really, really important to understand that. And the nice thing is your calculators are pre-programmed to obey this domain restriction. So even though if you look at it and you said 5 pi over 3, you typed it in to check your work, even though you think you're right, and then your calculator says, no, you're wrong, it might say, oh, yeah, if I'm going clockwise, it's negative. All right. Does that make sense? All right. I'm glad all of you made that mistake so it won't happen again. You know, I don't know about you guys, but I learn from my mistakes all the time. And I've made a lot of mistakes. All right. Number 4. What is the answer? 5 pi over 6? 5 pi over 6? Yeah, that sounds good. All right. My last 4 examples. I'm going to give all of you, let's do number, you guys want to do number 7 or number 4? Wow, that's okay. So obviously I have a little tape. 5, 6, this should be number 8, not number 4. All right. You guys want to do number 7 or 8 together? Okay. Let's do number 7 together. So the problem with doing tangents is we all know it's y divided by x. And then, you have to simplify and rationalize to get this number here. Well, so the problem is you can't just look at the unit circle and pick it out because they got this number by doing something divided by something. So here's the thing. It's actually quite easy to figure out because for tangent, we know the domain restriction is from negative pi over 2 to pi over 2. So we're either in quadrant 1 or quadrant 4. So in quadrant 1, your tangent is positive. In quadrant 4, your tangent is negative. Well, so if you notice over here, well, our value is positive. So it tells us it has to be in quadrant 1. Are we good so far? All right. Next, the answer has a radical 3 in it. Well, that tells us it really limits our choice, really, because there's only two places where you have a radical 3. You have a radical 3 at pi over 3, and you have a radical 3 at pi over 6. So the answer is either going to be pi over 6 or pi over 3. It can't be anything else. We good so far about that? And now it comes down to either being really good at mental math or guess and check. So we know that tangent is y over x. So all we can do is take the y value, which is 1/2, and divide it by the x value. So you would write 1/2 divided by radical 3 over 2. You do the, I'm not going to do it. You can do the math. You flip and multiply and you simplify. And when you do that, do we get negative radical 3 over 3? I'm sorry. We should be in quadrant 4. I don't know why I said. No, I'm looking at numbers. I keep bouncing it from 8 to 7. It's positive. So, sorry. 1/2 divided by radical 3 over 2, does that equal positive radical 3? One half divided by radical 3 over 2, does that equal radical 3? The answer is no, it does not. It actually equals radical 3 over 3. So, which kind of gives us the answer to the next one. But so that means if you were to do the math, you did radical 3 divided by 2 divided by 1/2. You did that math, you simplified, you would in fact get positive radical 3. So that means tangent of radical 3 is radian pi over 3. Like all of you are typing in chat furiously telling me to go on. Pi over 3. And you'd be correct. And you can always verify your answer by typing tangent or inverse tangent of radical 3, hit enter, and you get pi over 3. So neat. All right. That help you out on doing tangents? All right. Let's do a minute and a half for the remaining 3. Ready, go. Mhm. We got about 20 seconds left. Looks like there's a lot less people in here today. We're missing maybe about 10 people. Yeah. I'm guessing your teacher sent you email saying class was canceled. Some yes, some nope. Okay. Yeah, I didn't send one because I didn't cancel class today. I will do my very best to not cancel class when possible. So people who didn't show up and they assumed there was no school today because of meetings or whatever that teachers are doing. Surprise on Monday when we go on to the next lesson, right? Yep, yep. All right, number one, what is the answer? Number one, what is the answer? Ooh, all of you are learning very quickly. Negative pi over 4. Ooh, nobody said 7 pi over 4. Very good. Very good. All right, number 6, what is the answer? That one's an easy one. Yep, 2 pi over 3. Very good. And number 8. Thanks, Desmos. Negative pi over 6. We all agree with that? Negative pi over 6. Yeah. All right, and that's it. That's simple as it is. Some final thoughts I have, and there's my smiley face. All right, so your calculators have the domain restriction pre-programmed. Cool, right? This, however, will pose a problem later this term. Another smiley face. Yeah, so there's going to be a problem when we're not necessarily doing inverses per se, but the idea is going to be the same. And for example, like the inverse sine of like 1/2 actually has two answers when not talking about a function and a domain restriction. And your calculator will only give you one of the two answers. So I think we're doing that in unit 4. Maybe it's unit 4. I don't remember. It all blends together. So keep that in mind. Later, it's going to be a problem, maybe. That's why it's important to be able to use the unit circle to pick out the answer that way and also type it in. It's important both ways. All right, so we use the inverses. So yeah, so when doing inverses, I'm giving you the coordinate x, y, or y over x. So I'm giving you the coordinate, and you're giving me the angle, which is in radians. All right, check your answer. Spell that right. Check answer with calculator. Yep, that's important. Do both ways. So even though you pick it out, type it in, make sure you agree with your machine. All right, so simply put, this is what I said a few slides back. Inverses. So inverse trig functions. You're given a coordinate to find the angle in radians. Regular trig functions like cosine, sine, tangent, I'm giving you the angle and you're finding the coordinate. So that's simply put. And we did the second, this whole trig function, we did that last unit. So hopefully that makes sense. You guys have any questions? Pretty simple so far, right? So good luck on the quiz today. And as always, I hope you learned something.